Welcome to Fast Track Math. Suppose a teacher has the test scores of 200 students. Would you rather look at 200 individual scores or a sample frequency table? Frequency distributions help us organize large amounts of data and quickly estimate statistics like the mean and standard deviation. A frequency distribution is a table that shows classes or intervals and frequencies or counts. It transforms raw data into a readable summary. For instance, here we have a frequency distribution. We have classes from 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. The frequency represents how many values fall within that range. So there are 4 values that fall in the range of 50 to 59. There are 8 values that fall in the range of 60 to 69. There are 12 values that fall in the range from 70 to 79, so on and so forth. Class limits are the smallest and largest values that can belong to a class. For example, from 70 to 79, the lower class limit would be 70 and the upper class limit would be 79. Class boundaries are what remove gaps between classes by adjusting, in this case, by 0.5. For instance, for the class from 70 to 79, the boundaries would be from 69.5 to 79.5. So for instance, if I have a data value of 69.57, it will go into the class from 70 to 79. And class width are the differences between two consecutive lower class limits or upper class limits or class boundaries. There are many ways we can calculate the class width. So for instance, if I look at my first two classes, if I do the difference between two consecutive lower class limits, that will be 60 minus 50, which will be 10. So all throughout my frequency distribution, the class width will not change, it will be 10. So if I look at my first class, the lower class limit is 50 and the upper class limit is 59. My class boundaries would be from 49.5 to 59.5. And as you can see, even if I calculate the class width from the class boundaries, if I do 59.5 minus 49.5, I will still get a class width of 10. For example, if I say find the class limits, class boundaries, and class width for the class 80 to 89, well, the class limits would be 80 for the lower class limit and 89 for the upper class limit. The class boundaries would be from 79.5 to 89.5, and the class width is still the same, 89.5 minus 79.5, which will be 10. Now, we can use a frequency distribution to calculate the mean of a frequency distribution. When data are grouped like that, we use class midpoints as representative values. The midpoint formula is as such: the lower limit of a class plus the upper limit of that same class divided by 2. So if we have this frequency distribution right here with 4 classes, first class from 10 to 19 has a frequency of 3, second class from 20 to 29 has a frequency of 5, third class from 30 to 39 has a frequency of 7, and the fourth and last class from 40 to 49 has a frequency of 5. So here, the sum of all frequencies, if we do 3 plus 5 plus 7 plus 5, that will be 20. We can now calculate the class midpoints for each class. So that will be the lower class limit plus the upper class limit divided by 2. So 10 plus 19 divided by 2 is 14.5. 20 plus 29 divided by 2 is 24.5. Or you could simply calculate the first class midpoint and simply add the class width to the subsequent classes, because we know that the class width doesn't change throughout the whole frequency distribution. Now, in order to calculate the mean, we will need to calculate the frequency times the midpoint for each class. So if we do 3 times 14.5, that will be 43.5. 5 times 24.5 will be 122.5. 7 times 34.5 will be 241.5. And 5 times 44.5 will be 222.5. If we sum up the frequency times the x value, that will be 630. Now we can calculate the mean. The formula is as such. The mean of a frequency distribution is x bar equals the sum of the frequency times the x value, which in this case we use the midpoint, divided by the sum of all frequencies. So substituting our values, x bar will be equal to 630 divided by 20, which is 31.5. So the mean is 31.5, but this is an estimate because we used midpoints to represent all values within each class interval. The more data points in each class, the more accurate this estimate will become. We can also calculate the standard deviation for group data. The formula for standard deviation of group data is S is equal to the square root of the sum of the frequency times the deviation from the mean squared, so x minus x bar squared, divided by n minus 1, where n is the sum of all frequencies. X, in this case, we will use midpoints. So using the same table that we used in the previous example, and we found the mean to be x bar equals 31.5. So we're using our midpoints as our x values. The frequency doesn't change. Now we will calculate for each x value the deviation from the mean squared. So we'll do 14.5 minus our mean of 31.5 squared. And then we'll do that for each of the classes for each midpoint. Once we find the deviation from the mean squared, we can multiply the frequency by the deviation from the mean squared. So 3 times 289 will be 867. 5 times 49 will be 245. 7 times 9 is 63. And 5 times 169 will be 845. So the sum here will be 2020. Now we can use our formula. S will be equal to the square root of 2020 divided by 20 minus 1, which is 19, which will be approximately 10.31. So in this case, the standard deviation for our frequency distribution will be approximately 10.31. And once again, this is an estimate because we used midpoints to represent all the values. The more data points in each class, the more accurate this estimate will become. Here's your challenge for today. We have this frequency distribution with 4 classes from 50 to 59, 60 to 69, 70 to 79, 80 to 89, with respective frequencies 4, 6, 8, and 2. Find the class width, find the midpoints for the class from 70 to 79, and find the estimated mean. And please, drop your answers in the comments below. These 5 ideas solve most frequency distribution problems. So remember that frequency distributions organize large data sets into classes and frequencies for quick interpretation. Class limits are the shown endpoints. Boundaries adjust by 0.5 in this case. And the class width would be the upper minus the lower boundary, or the difference between 2 consecutive lower class limits. The frequency is the count per class, and we can use midpoints and the formula to estimate the mean, and we can also use midpoints and the formula to measure the spread in group data. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.